Good afternoon, everyone. Good afternoon, all my friends on this platform. Just a check. Can you hear me loudly? Am I audible? Can you please just put your comments on the chat box and say thumbs up? Okay, thank you. Thank you so much for your response. Friends, I'm delighted to see you all after a long gap of 9 months. Last webinar, we had it on 24th of August, 2022 for best available technology for mustard and paddy straw. I'm seeing many new names and the faces, which is very, very encouraging for me. First of all, I express my gratitude and extend my warm welcome to all the attendees, especially for not losing the momentum even after a long gap. During the last 9 months away from this platform, we were busy crafting 3 success stories for you. One of them on ESP upgrade is being presented today in this webinar. The second success story is going to be on the first of its own kind, a special type of bag filters on 100% mustard husk application in northern India. The third success story, and which is truly special, is on second EGB installation on a slow fired boiler. So these case studies shall be shared with you shortly through separate webinars. Today we are going to do it on ESP upgrade in a sugar mill. Friends, you know, in almost all areas of our life, we have started touching or even surpassed pre-COVID scales, be it social, economical, or spiritual. Industrial production is booming. You can see our GDP growth, which is better than expected. And we are making good progress to become manufacturing hub, probably surpassing China in this decade itself, if everything falls in place. So thank you very much for your efforts. We all are in the manufacturing sectors, and it is our duty to continue this momentum. However, on the flip side, this pace of industrialization is going to throw many challenges towards environment. The brighter side is that the government or the present date government, the industries or public at large are well aware of this threat. This is exactly the reason the government is proactively engaging industries to reduce the air emissions. My sole objective of bringing this webinar at this juncture is basically to keep you informed about possible ways and means to upgrade your existing APC devices to meet more stringent norms in a most economical way. Friends, this presentation today is going to be in 2 parts. It is divided in 2 parts. First part will provide you enough arms and ammunition to take a decisive call on upgradation of your existing APC system. The second part is exclusively devoted to a case study from a very reputed sugar mill in southern India, that is Pony Sugar. Today, we are very fortunate to have with us Mr. B. Chandrasekharan, Senior Vice President of Pony Sugar. Thank you, sir, for sparing your time.
Thank you.
Friends, he is the man behind the success story. We shall have opportunity to hear his side of the story as an end user of that upgrade. At the end of the presentation, I will also introduce 4 hybrid technologies to remain future ready, even to meet European standards in years to come. Guys, it is going to be a very interesting and interactive section as usual. Today, I would like each one of you to stay connected till end. My backend team will also issue participation certificate to all the participants after the Q&A session. And at the end of this message, as you know, every new learning needs some discipline. Without discipline, you cannot learn anything. So let me just remind you about the ground rule of this session. Please, please maintain high energy. Be active on the chat box. Put lot of questions in the Q&A session. And whenever you feel that something is not going, you are not able to understand or not following it up, just put your comments on the chat box. Preferably put your phones on the silent mode so to avoid any distraction during the webinar. Be interactive and use your fingers as much as possible to communicate through chat box, and hold your questions for the Q&A round. When the Q&A round is announced, you start putting your questions in the chat box so that I can read it one by one and try to reply whatever best is possible in the given time. And last but not the least, please honor the IP and do not click the pictures of the slides. If you find something very interesting to you, please put your comments in the chat box. My backend team is writing all those notes, and they will make sure that they send you the extract of the presentation as soon as possible. So thank you so much. We are ready to start with the presentation today. So hope everyone is with me so far. If yes, please write yes in the chat box before I start the presentation. Thank you so much for your... Is the screen visible to everyone? Is the screen visible? Can you just give me a thumbs up in the chat box? Full screen is visible? Okay, thank you. So let us start today's journey of new learning, and the presentation is going to be on innovative ways to upgrade your existing APC devices. While crafting this presentation, the care has been taken to have more innovative ways without salvaging or without wasting the existing investment on your equipment. What best can be done in a different scenarios. So all those innovative ways has been defined or has been given in this presentation that may or may not be applicable to one site, but may or may be applicable to second site. So it depends which one is more suitable for you. You can pick and choose. This is the total ammunition and arms which we are going to present to you, the different way of modifying the different kind of pollution control system. Can you see the second screen now? Just is the screen changing? Yeah, okay, thank you. So, friends, what we are talking today, you can see from this graph. Just a moment. Bringing down the emission levels from 150 to 50 on an agro-based scenario, be it sugar industry or other industry using the agro-based fuel, how does it impact the environment, and what is going to be our contribution to the environment or to the mother nature or to our next generation's health? It implies from bringing down from 150 to 50 is almost amounting to about 400,000, that is 4 lakh tons of fine dust going to the atmosphere. We will be preventing 4 lakh tons of fine dust, which is below 10 micron, going to the atmosphere every year from the biomass industry only. So this 100 milligram change is a big contribution to the society, is a big contribution for our next generations. And if you look at the type of particulate from a biomass, you can find that particulate in a boiler, especially on bagasse fired or near to the bagasse firing type of biomass, you have around 7 to 8 grams, or more specifically, it varies from 6.5 to 7.5 grams per normal meter cube of dust emissions from the boilers of biomass. And as regard to the particle size distribution, you find that there are approximately 15% particles which are below 10 microns. So in any air pollution control device, the crux is to capture these below 10 micron particles. If you are able to successfully do that, the bigger particles will automatically get settled. You don't have to worry at all on the particles above 10 microns. So any design or any particular APC system has to be more focused on the fine particulate matters. And when we talk of reducing from 150 to 50, basically we are talking about below 10 microns, because if some system is already bringing it down to 150, that means majority of particles above 20, 30, 40 microns has already got out. So our focus is only on the below 10 or 20 micron particulate. And if you look at the technology progression in India, in APC system, you can find there are two types of technologies available. One is dry separation, other one is wet separation. I think you all know the dry separation started in 1970s with gravity settling chambers, followed by cyclones and then multi-cyclone dust collectors, then back filters, then ESP. And latest in the series is a combination of ESP and EGB called MEPA, maximum efficiency particulate abatement. As on date in the world, this is the most efficient dry separation technology. On the wet separation, we started converting the cyclone into a wet cyclone, then became the wet systems, especially for particulates having very light density, which were difficult to capture, especially the biomass or a very fine particulate where the density is very low, and capturing in this dry state is very, very difficult. It demands very high pressure drop and high energy to capture that. That is the reason the existing cyclones in 1970s and 80s were converted from cyclone to wet cyclone. And then it followed with a high energy Venturi scrubbers, spray scrubbers, sieve tray, fluidized bed nitrate, and the latest scrubber is fixed vane scrubbers. And wet ESP is the latest or the most advanced technology in the world on wet systems. So I'm sure this is clear to you so far. So are you following me? If yes, please write yes in the chat box if everything is loud and clear so far. Please write L and N if it is clear. Okay, thank you. Now, as we know that if we talk of biomass industry or biomass fired boiler, the sugar industry is the major contributor. Almost 50% is sugar industry where the bagasse is used as a fuel. So if you look at the spread of different kind of APC system in the sugar, as on date, you find there are approximately 850 wet scrubbers. There are total 500 sugar factories and 850 scrubbers are there in India. Whereas the ESPs are to the tune of about 380 to 400. Wet ESP is only one so far at Dorala Sugar. There is no back filter in sugar industry, especially on bagasse fired boiler I am talking about. We will talk separately on slope fired or the spent wash. There are still multi-cyclone dust collector in very old boilers of a small capacity to the tune of 70 to 80. And then we have other type of systems which have different kind of like baffle type of separation, U-bend type of separation. So this is what is the overall spread in the sugar industry on various type of APC systems. And if you look at the type of scrubber, 850 roughly, you see that tray type scrubbers are about 630. Whereas the this Venturi scrubbers are to the tune of about 180 to 200. Pitch drain scrubbers, because it has just started few years back, there are approximately 50 to 60 as on date. Spray scrubbers are very few, which are very old installations, still running in some of the factories. Then there is few scrubbers still left on rotating disc type, which used to be made by Stein Technology from Haridwar. And then there are other type of locally made scrubbers, combinations of different type. So this is the overall spread of the APC system and the most familiar wet scrubbers in the sugar industry. And which are the most common technologies on these biomass? If you look at the status, the ESPs are normally there, which are designed from 80 to 150 milligram, 2 to 4 field of ESP. Then we have bag filters on, not on bagasse, but it is on there on rice husk or wood chips, especially on non-sticky type of dust. Bag filters are designed from 50 to 80. This is the current scenario across industries, sugar or non-sugar. And then we have wet scrubbers designed for 100 to 150 outlet emissions. And the type of scrubbers which are very common in the industry is a spray, venturi, and tray type. Right? So these are the most common technologies across industries. Now, we know the spread, we know what type of systems are most popular in the industry. And we also know our target to bring down from 150 to 50. And we also know the problems. So now we have to have the solutions. How to do. One solution is you discard everything, put something newly designed at a higher efficiency. The other way of approaching this issue is to find out ways to have the modifications or the alterations in the existing systems and still achieve 50 milligram. So we will be talking in this webinar, or in this session, we will be talking how to achieve 50 milligram for the plants having ESPs, for the plants having back filters, for the plants having wet scrubbers, and what are the possible upgrades for liquid fuel fired incineration boilers like a spent wash or black liquor in paper industry, and what is the way forward for us to meet the European standards. If not today, maybe after 10 years down the line, we will have to do it. Okay, so this is the flow of the session or the presentation we will be taking up. I'm sure everyone is following so far. Please say yes if everyone is okay with the speed or with my voice. Okay, thank you. So let us start with the ESP. What are the different ways of improving the efficiency of ESP? There are some conventional way of doing it. I think most of you must be knowing that if you talk about ESP upgradation, the first thing comes in mind. If it is 2 field, add 1 more field. If it is 3 field, add 1 more field. So this is a very conventional type of doing this upgrade. So what we field addition, or sometimes the another way of doing it to improve upon the TR set, going with single phase to 3 phase to smart TR sets, high frequency, which are available today. This is another way of doing it. Or in some cases, you can increase the field height. Or in some cases, the emitting electrode could be made double spikes. So these are the very normal and conventional way of upgrading a ESP to reduce the emissions from the design figure, right? What is the other way? Other way that is also very, not very much popular in India, but outside India, I've seen many installations which has converted ESPs into a hybrid filter, converting the last field into a bag filter. So if it is 3 field ESP, convert the last field into a bag filter, insert the bags and make it. But the demerit of this is that on a hygroscopic type of ash, it doesn't work. Because after 2 or 3 fields, when you left only with fines which are hygroscopic in nature and having a biomass in picture, then it tend to choke or the deposits on the bags, which are difficult to purge. So this is the way of another way of improving upon the efficiency of the existing ESP. And the third, which is the most innovative way as on date, is to convert into ESP into a MEPA. MEPA is a combination of ESP with EGB. Many of you may not be know what is EGB. EGB is electrified gravel bed precipitator. It's a different kind of ESP, vertical in nature, where the gravels are used as a collecting surface area. Right? So I'll just explain about this new technology. So within the same footprint, you don't need any extra space. In the outlet funnel of ESP, you can just mount these two vessels, and these are the EGB vessels. If you look at the side view, this is something like this, and take emissions down to below 20-30 milligram, or even it can go much lower if you design it. I have seen EGBs running in Sweden with 6 milligram outlet emissions. For last 15 years, the installation is 15 years old. So this is the most innovative way of doing the ESP upgrade. So let me explain you how EGB works. EGB is basically two cylindrical vessels where there is a thick bed of gravels. Gravels are the stones, peak gravels. And the gravels are embedded with emitting electrode, which is given a high voltage, right? So the gravels conduct of electricity, they do not migrate or generate current. So what happens when the high voltage is passed through the gravels get polarized. And when this gets polarized, the half of the gravel surface gets a negative charge and other half gets a positive charge. So when the left out particles coming from the ESP is having a negative charge pass through this bed, they get deposited, the particles get attracted and deposited towards the positive side of the gravel, and the clean gas goes upward. And when this bed of gravel is moving from top to bottom at a very, very slow speed. So by the time gravels are coming out from the system, they are fully coated with the very fine ash. These systems are known for separating below 5 micron particles very, very efficiently. Okay, so and then gravels are cleaned outside through a gravel cleaner and then put back into the system. It is a closed loop system to reduce the particulate emissions, very fine particulate emissions of below 10 micron, 5 micron. So this is a basic concept of EGB. These are the internal parts of EGB. You have this inner lower, outer lower, in between there is a gravel bed, then gravel cleaner, then bucket elevator, which takes the gravels from bottom to top. So this is the internal construction. And if you look at the gravel bed, how it moves, you can just look at this video on left hand side. Very slowly, gravels are moving downwards and gas is passing through this directed at 90 degrees. And this gravel from top to bottom takes about 7 hours. So by the time gravels comes out, it is completely coated with very, very fine ash. And after it is coming out from the gas stream, the gravel cleaner cleans it pneumatically, and clean gravel goes upward and put back. So it keeps running. If you look at the efficiency curve of this particular device, you find that with the voltage on, and when I say voltage is maximum 15 to 20 kV, you find that collection efficiency is almost 100% up to 2 micron particulate. And even if your TR set is off, the gravel filter becomes a mechanical filtration, still you have an efficiency of 90% up to 2 micron, which is much, much better than ESP, the conventional ESP. So this is what is the polishing filter. We use it as a polishing filter. And you can see how the gravels coated with dust in a spent wash fight boiler are coming out. So what we are seeing here, very fine dust over the top of the surface of this gravels is nothing but the potassium K2O, which is coming in the huge quantity in the spent wash white boiler, which is very, very hygroscopic, very, very sticky, and it has lots of difficulties in normal ESP because the collecting plate does not get clean by wrapping. But here, because the gravels are coming out of the gas stream, there is no threat of re-entrainment or back to the gas stream. So you can clean it as clean as possible, right? And then after cleaning, this is the color of the gravels. You can see the difference in the color. So this is the comparison between normal ESP and this EGB. EGB has got a large collecting surface area because of the gravel surface. There are in one vessel has got about 70 to 100 tons of gravel. And if you compare with normal ESP, the collecting surface of those gravels are 10 to 20 times of ESP, and the footprint is almost 1/4. Okay. Gas distribution is not a problem here because the gravel poses resistance, and because of that delta P, there is no need of any gas distribution. That's automatically spread. Power consumption here is very low because in the TR set the power is zero. There is no current. We are only playing with the voltage. So power on the TR set is zero. Only power which is required is to push bring the gravel from bottom to top in the bucket elevator and a dedusting fan, which is very small, 10 watt per 1000 meter cube per hour. Wait a minute. Just a moment. I think sound is not coming. Hello. Yeah, am I audible? Okay. Sorry. So larger collecting surface area, evenly gas distribution, low power consumption, high efficiency on very fine particulate matter, and another big then migration of the particles is very low and the efficiency goes down. But here in this case, resistivity does not play any role because we are not using the current. We are only using the voltage. So it can handle high resistivity dust as well. No wrapping re-entrainment, as I explained, the gravels are cleaned outside the gas stream. And it is a modular design and very smaller footprint if you compare with other technologies. Okay, now these were the three upgrades of ESP. One was the conventional way, and then one was the smart way of doing it, and the third one was the most innovative way of doing it. Correct? Now coming to the back filters, I think most of you must be aware the back filters, the first and foremost modification which comes into the mind as soon as somebody wants to increase the efficiency is that reducing the air to cloth ratio. That means adding the modules. If it is a 3 module, you add 1 more module. Reduce the ACR and increase the efficiency of separation. So that is the most conventional way. The other way could be to replace the bags from the normal bags to the plated bags. Plated bags gives you more surface area, and that is why the efficiency goes up within the same module. So this is another way of doing it. The third way, which is again a very smart way of doing it, but this technology is not available in India so far, is converting the back filter into an electro back filter, where the gas is charged before the back filter and it allows the conglomeration of particles over the surface of the bags itself. So this technology is not there in India, but in some European countries, people have successfully tried it and increased the efficiency of back filter by converting into normal back filter to electro back filter, right? So these are the three upgrades of back filters. Now coming to the wet scrubbers. Wet scrubbers being the most common technology which is available in the industry on biomass fired boilers. In most of the places you find back filters on biomass. Not only in India, even in many other countries, the wet scrubbers are widely used on these applications because of many reasons, like maybe fire hazard on biomass in fired boilers, light density, or maybe because of certain norms. So if you look at the wet scrubbers, these are the 4 types of scrubbers which are commonly available in India, and how to upgrade these. So we have launched a scrubber recently after this norms came to 50 milligram. This is called EMSS, which is the Enviropol multi-stage scrubbing system. So this is the model of multi-stage scrubbing system. It is basically having 2 to 3 type of scrubbing in the same module. You have a pre-scrubbing and then another scrubbing, and then the final scrubbing or the polishing of the flue gas. So this is converting from normal wet scrubber to EMSS. Almost all type of scrubbers can be converted into this multi-stage scrubbing. So you don't have to discard the scrubber if the vessels are okay, if it is not corroded, it is not old, we can reuse that by adding features of multi-stage scrubbing in the scrubbers. So another way, when you want to be assured of 50 milligram or even less than 50 milligrams on the scrubbers, you can convert wet scrubbers into wet ESPs. Now, I'm again coming with a new word. Many of you may not have heard about the wet electrostatic precipitators like EGB. So wet ESPs are very similar to the normal ESPs, but they work under the wet environment or the saturated gas environment. So at many places in Sweden and US and even in countries like Poland and Slovenia, people have successfully converted their old wet scrubbers into wet ESPs. So this is the methodology of converting. You have the scrubbing section at the bottom, and then you put up the electrodes. This is the electrode bundle, which has a collecting electrode and the emitting electrode. And then you have a high voltage this frame, and then insulators. And then TR set is connected on that. So gas is first scrubbed. The gas is saturated in the scrubbing zone, and then the wet particles left out after the conditioning of gas goes to the electrostatic precipitation, and the gas is charged very fast as compared to normal ESP because of the water content on the surface. Water being a good conductor of electricity, the charging of particles is very fast and their migration is very, very fast. So the efficiency of wet ESP is much, much higher than the normal ESPs. So this is the working principle of wet ESP. Very similar to normal ESP in terms of the principle, except in the first and last stage. The gas conditioning has to be done before it is charged. That means the gas has to be saturated. And then corona generation and charging is similar process. Migration and precipitation is also similar process. Then removing of particle is different. In normal ESP, you do the wrapping. Here you do the washing. So once in every few hours, depending on the dust load, you just a automatic washing cycle is there that wash the electrodes, and you get a slurry output around 2 to 3 meter cube every 4 to 5 hours. And then that slurry is separated with solid separation, and water is recirculated back. So this is the principle of wet ESP. And if you look at the comparison of all type of systems, you find the wet ESP being the most versatile across all the systems, conventional systems. Am I going too fast or the speed is okay? Can you please tell me on chat? Please write if it is okay, the speed is okay. Okay. Thank you. So this is what is the comparison across the systems. So another way of upgrading your scrubber is to convert it into a hybrid scrubber, hybrid dryer. This is a concept of gaining while greening. You add a bagasse dryer or a biomass dryer before the scrubber and then make it a hybrid model. The hybrid can be with wet scrubber or wet ESP both. So this way you can reduce the emissions and as well as you can gain on moisture reduction by 10 to 12 units depending on the temperature of the flue gas. So it is a revenue generating model. You can save your fuel by 6 to 8%. At the same time, you can also reduce the emissions down to 50 milligram in this particular model. And the most sought nowadays is this hybrid model of bagasse dryer, which we call it as a hybrid wet ESP. And the dryer is attached with a wet ESP. So what you are gaining out of it, you are cleaning the environment down to below 10 milligram if you want, and at the same time reducing the moisture of the biomass or the bagasse by from 50% down to 38 to 40%. So this is a revenue based APC model where the ROI is varying from, if I tell you in the number of days, then it is approximately 400 working days of a sugar industry. So about 3 to maximum 3 seasons. And this model can be applied to other biomass also, maybe pith, bagasse, pith, wood chips, rice husk if the moisture is high, or many other biomass. We are conducting some trials on different kind of biomass with this kind of model. And this is a revenue generating model for emission control. If you look at this, just see this hybrid model and see the color smoke. This is the first installation of the bird on a 90 TPH boiler, where the APH distance between air preheater and chimney is only 12 meter. And within 12 meter, you have the dryer and you also have the wet ESP inbuilt. You can just see this is the dryer portion and this red color is the wet ESP attached to it. And you can hear the emissions are about 30 or 27 milligram. And the moisture reduction is from 50% down to about 40 or 39% on an average basis. So this model is a revenue generating for the end user in terms of saving on fuel by 6 to 7%. And this is a patented technology of EnviroPol, and we have been awarded the CII best most innovative product and saving product of 2021 on the particular model. Now coming the next type of boilers is the slope and black liquor, which is the liquid fired boilers. And on the slope fired boiler, if you look at the spread of APC system, you find that wet scrubbers are very few. Mostly dry ESP and back filters are in operations on slope fired boiler. And there is 2 MEPA systems which are recently being done by us, converting ESP and adding the EGB with it. Okay, so how we can do the upgradation of these type of systems in a distillery or a sugar industry producing, having the incineration boiler. So there are 2 type of upgrade which can be thought of on a back filter and on a ESP. On back filter, there is a possibility of upgrading it by changing it from back filter to cyclo back filter, that you can think of putting up a cyclonic separator, tremacyclone, or especially designed to take care of the 50 to 60% of the efficiency maximum, followed by the existing back filter. So once you reduce the quantity of dust, then you have a better collection or the better efficiency of the outlet emissions. Then, as I explained, converting ESP into MEPA, adding the EGB with the ESP and convert into MEPA. This is at Dorala Sugar, the incinerator. And this is another one recently done. It is under a stabilization period at Dalmia. You can see the EGB And you can see the collection of fine ash on the right hand side from EGB after 4 field of ESP. This is under testing, and we will be presenting a case study once everything gets stabilized and the data is available after testing on this particular installation. You can see how it is going now. And for the attendees who are from the paper industry, I have got a very good solution to convert the black liquor fired boiler ESP, adding the wet ESP with it. This has been done by our counterpart in Sweden. The installation is running with 1 milligram outlet emissions for last 4 years. 1 milligram, I repeat, it is 1 milligram. On the testing results continuously are showing 0.7, 0.8, all below 1. Gas flow is about 150 to 1000. So here there was a ESP, conventional ESP, 2-stream, and then it was an economizer, and then you had a scrubber to condition the gas to make it saturated, and then followed by wet ESP modules. And the outlet emissions are running from 0.7 to 1 milligram. In India, there is no installation on chemical recovery boilers yet, but we are discussing with a couple of paper plants very seriously to introduce this new technology in paper industry. So technology part is over. Now we will be discussing a success story on ESP upgrade from Pony Sugar. So I'll just brief you about the work which has been done here. And then I will invite our guest today from Pony, Mr. Chandrasekhar, to give you a little brief about his experience on the operation of this particular system. So as you know, the Pony Sugar is a very prestigious sugar plant in southern India in Erode, and it has got a paper plant also nearby. So their bagasse is going to the paper plant, and then pith is being used in the boiler. The boiler is a multi-fuel fired boiler designed by CVL, 95 TPH capacity at 109 bar. And it's a company which is known for technical innovations and doing good technical things in the industry. It has got a sugar plant and a cogeneration plant, where it is the cogeneration excess power is connected with the national grid. It's a standard cogeneration plant. And this is what is their layout. If you look at this boiler, this is the boiler. And then they have the ESP of 3 field followed by ID fan and chimney. This is the turbine hall, and then air-cooled condenser. It is one of the most cleanest plant of India, very clean, and just on the bank of river Kaveri. This is their cogeneration cycle. It's a very standard cycle where this extraction is there at for the process and for the deaerator, and the power is generated and used in the sugar plant and also connected with the national grid. So they had some problem. We got connected with them in the COVID, during the COVID, or I would say just after the COVID, first wave of COVID. And the problem statement given by the company was basically they have a boiler of 95 TPH, 112 bar, traveling grade boiler. It was installed in 2012 by CVL, Sithar vessels. The boiler is designed on multi-fuel, bagasse, pith, Julia flora, husk, or even coal as a supporting fuel. They have an ESP of 3 field, and emissions, though they were meeting the emission norms of below 150 milligram from this ESP, but they had a very typical problem. And the problem was that very small, tiny balls of dust were visibly spreading in the vicinity and causing unrest among the farmers. It was not continuous. It was within certain period when the wind direction changes, and these very fine tiny balls were going and creating a havoc in the nearby. And plant being located at the riverbank of Kaveri, the management of Pony Sugar was very, very particular to resolve this problem, even if it cost them heavily or it can be solved. So there were a lot of discussions which they have been doing with different agencies. And they explored ESP field extension. They also explored converting the third filter of ESP into a back filter. That was also under discussion. And they also explored at one point of time to install biomass dryer so that their emissions can be reduced. And then placement of EGB in the downstream was also explored. We were also part of this discussion for a long time. Then putting up a deflector on the top of chimney just to divert or deflect the tiny balls not to go to the farmer's land. This was also being explored, that how to come out of this problem, because norms was never a problem for them. Norms, they were mostly getting below 150 or even 100. And then the last one was the efficient, putting up efficient wet scrubbers. So out of that, the final conclusion was to go for a good quality of wet scrubber. And it had lots of consideration when they finally decided to go for it. Installation of biomass dryer was ruled out because it has a little high investment. And ESP field extension, the confidence was not coming basically, whether it will give us the right result or not. And EGB being the new technology at that time, they were not feeling so much confident on EGB, putting up the EGB after the ESP. So finally, it was a decision by the team of Pony Sugar, headed by Mr. Chandrasekhar, to go for a good quality of a scrubber in the downstream of ESP. And I think this is maybe the first or second installation in India which has got a wet scrubber after ESP. However, even if they decided for wet scrubber, they had lots of concerns in the mind. And there were lots of discussion, extensive discussions took place. I myself visited a couple of times before we finally make this deal. And the concerns were related to the choking and high pressure draw, which is normally there in the wet scrubbers. I mean, it is wet scrubber technology has been abused by many, I would say, I'm sorry to say, but it has been abused by many small suppliers. That is the reason it has got a bad name in the industry, that wet scrubber means choking, dirtiness, slurry handling. All these myths are coming into the mind of the user when they talk about wet scrubbers, right? Whereas the truth is entirely different. Wet scrubbers can be designed as good as clean as normal other systems, right? And the other concern was low temperature of flue gas going from the stack and a visibility of white plume coming from the stack. So these were the concerns which were addressed, discussed, and then finally concluded. Other design consideration was basically because they are using multi-fuel. It is not only pith or only bagasse. They have a multi-fuel firing scenario, and especially during soot blowing conditions, the emissions were going high. That was another concern which was considered while designing the wet scrubbers. So during soot blowing, and sometimes when there is a change in fuel, suddenly the peaks are coming. So that a smooth curve was not maintained. And when the scrubber was designed, it was designed to give them the continuously below 50 milligram outlet emissions. And it was also discussed that because they had a space behind the chimney, so that a space was utilized to reduce the installation of wet scrubber, and left out fine particles, whatever is coming out from the chimney. The scrubber was designed to capture very fine particulate emissions. And they found, finally, after considering all these, they found that this looks to be the most economical solution with diversified benefit in terms of PM. And suppose in future they put something in the boiler which has got a sulfur content. So this scrubber can be reused as a desox scrubber also after making small changes. So these were consideration of different kind which went in favor of selecting the wet scrubbers. Another thing which now being appeared, and it was also that time we were thinking that because sugar sector is being brought under PET by BEE, Bureau of Energy Efficiency, the focus and stress was on reducing the specific emission, this energy consumption, SECs. So idea was basically not only to reduce the specific emissions in milligram per normal meter cube, but attempt should be made to reduce the absolute emissions. That means you increase the efficiency of the boiler, reduce the consumption of fuel, and also contribute to the overall emissions or the absolute emissions on the from the boiler. So this calls for increasing the thermal efficiency of the boiler. So this is what were the consideration when the decision was taken. And now I'll just give you the design data. The scrubbers were designed for 76 meter cube per second. Though the outlet emissions from the ESP was very low, it was the scrubbers were designed for a high emissions just to take care of any unforeseen condition or bypass of any field of the ESP. Inlet temperature was 135. Maximum pressure drop across a scrubber was designed from 120 plus minus 10 millimeter. Emission target was 50 plus minus 10, and the location was after the ID fan of the boiler. And slurry handling, because they were very particular because of the Kaveri river, that we should not have any liquid effluent generated from scrubbers. So they went with mechanized slurry dewatering and the 100% recirculation of the water. This was the design layout of the scrubber. These were the ID fan. Here is the ESP. And from the fan outlet, the tapping was taken from both sides. And then we put up a booster fan. And then outlet of booster fan was given to the scrubber, which is a fixed vane scrubber, 2 scrubbers. And then outlet of a scrubber was connected to the inlet of chimney. So this was the layout. And this was the model. If you look at the right hand side, there are 2 scrubbers of fixed vane type. And this is the photograph of actual installation. You can see the ESP at the back, chimney in between, then scrubbers and behind the chimney. And then you have a booster fan connected with the scrubber, and outlet of a scrubber is connected back with the chimney. This is the test report done by third party. You can see milligram per normal meter cube is 22.4. This was done after the PG test in the year 2022, I suppose. Yeah. And then they had also have a continuous monitoring system, and that graph is also showing always between 20 to 30 millimeter consistently, despite the fact the soot blowing in the ESP is taking place, despite the fact the fluctuation in the ESP current is also taking place. Their outlet emission is maintained well within the limit now. And if you look at the this is before we put up the scrubber. The chimney was sometime going this type during the type of soot blowing. And now after the scrubber installation, it is more or less running very, very clean. This is the control desk of scrubbing system. The right side is a downstream mechanized with a sludge dredger, where the 20% of this bottom of scrubber is coming here, separating ash is going back, and rest of 80% is continuously going through the scrubber in a recirculation mode. Because the dust content is very, very less, so the circulation of 80% is possible without doing anything. Now, I would request Mr. Chandrasekhar to share his experience on operation side of this during the last 2.5 years of its installation. So over to Mr. Chandrasekhar. Thank you very much for your presence and sparing time. Thank you. Please go ahead.
First of all, thanks to Enviropol team for inviting me to give my expression or experience on this installed wet scrubber by Enviropol. See, as Mr. Rajesh was telling, our factory, we have installed a cogeneration power plant in the year 2012. Actually, since we have to supply entire bagasse, not bagasse, it is the fiber portion of the bagasse, we have to give it to the paper mill, our adjacent paper mill, and the rest pith alone is fired in the boiler. So to meet out the deficiency in the fuel, so we are procuring all sorts of biofuels, like the major portion is Juliflora. That comes to around 50 to 60% of our fuel requirement, and about 30% comes from the pith, and the rest 20%, about 5 to 6% from coal, the rest 10 to 12% from the other biofuels. Whatever biofuels we used to get, we are getting, and we are mixing it. Our boiler operation, it definitely, because of the various fuels usage, it is very unsteady. And in all the probability, we have to operate the boiler with a very steady condition. So it was a very, very difficult task for us. Of course, we have done a lot of automation everywhere, and definitely we have been maintaining consistently. But still, because of some uncertain conditions, definitely the SPM levels will be oscillating. Will be changing from it will be, sometimes it goes 100 or 120, or during soot flow time it may cross 150 also, sometimes. So our factory is one side it is River Kaveri, other side it is paper mill, the other side is the village. It is not the farmers what he has pointed out, it is a village, so which is flooded with a lot of houses. So especially during the southwest monsoon period, our wind direction is towards the village. Because of that, some abnormal conditions in the boiler operations, all the dust particles, if the SPM goes above 100 or so, 120 or so, definitely the dust particles will be falling on the houses nearby, and definitely there are a lot of complaints will be started coming. The other problem, the tiny balls, what he was mentioning, that was happening whenever boiler, whenever it is going on full load, it is getting tripped suddenly because of some grid fluctuations or due to some boiler problems. If it gets tripped, immediately that biomass of that small lumps like that thing, it goes. It is a like pasty thing and a sticky mass. It definitely it was falling into the houses of the villages, which is causing a lot of problems to us. Though in a year, at least twice or thrice this thing was happening, and we are unable to convince our local village. So in that scenario, we have been seeing like this webinar. I have been seeing the webinar, I think 2 years back by Mr. Verma. And we were speaking over phone through him regarding our problem, and he was telling that okay, we will definitely I will make a visit there and I will study all the problems. So we have, as he was mentioning in this presentation, we have been doing a lot of research on this, and finally we came to the conclusion of erecting this fixed wet scrubber. I think 2 years back we installed, and for the past 2 years we have been running the system. So after running the system, definitely our the SPM levels have not gone above 60 or maximum above 65. We have never crossed 65. So it will be within 65 only under any conditions, because this wet scrubber is taking care whatever the fluctuations are happening in the boiler. So our final SPM is less than 60, 65. That's all. It has never crossed 65. Number one. Number two, that whatever the sticky mass going over the village during any tripping time, that has not happened. So whatever, whenever that happens, whatever the mass generated, it comes to the water of the wet scrubber. So it is sprayed and it gets dissolved and it comes to the system in our system only. And it is taken care of by the dredger. That sludge will be removed by the dredger. So these problems have been solved. The only slight concern what we have encountered with this operation is number one is because of the we are using multi fuels. That fuels may contain some other chemicals also. So because of that, and the temperature also is the flue gas is also after the wet scrubber, it will be around 100 degrees centigrade. So definitely that because of some sulfur content SO2, that is sulfonic acid, and CO2 means carbonic acid. Because of the acid, some corrosion was happening into the wet scrubber shell. So what we did last year immediately, because this aspect we have not conceptualized while conceiving this idea of putting this project. So it is the mistake of us as well as by Emiropol also. We have not, of course, clearly told the multi-fuel characteristics, everything, and they have also missed out the this thing point, and we have also not aware of this problem. So this problem has come. What we did immediately, we have a patch welded, and immediately we have put a small milk of lime solution in auto mode. So that the pH of the water comes out of the scrubber is maintained around 7. So accordingly, we have made an auto system with whenever the pH goes below 7, the slight lime addition will be there in auto mode. So after that, the problem has not solved. Now this year, we have completely changed that wet scrubber bottom portion with the SS code. So I think this problem will not come because already we have added a milk of lime solution. After the addition of milk of lime, the problem has been solved. So this is, and definitely this equipment is working nice. But the other problem, this thing is it's not a problem because of the addition of boost ready fans and pumps and the dredger chain, etc. The power consumption, even your the existing ID fan also, that power consumption will be less. So net that extra power consumption will be to the tune of 2,000 units per day. That extra units will be there. It will be around say about 75 to 80 kilowatt. That extra power consumption will be there, but it is definitely it is helping us to resolve the village society problem. So that's why we are this thing. And if you want to stop the wet scrubber also, because the windy season is not towards the village side, yeah, we can stop the operation of the wet scrubber in that also when you want to save the power. So overall, the system is giving a good this thing. I think hereafter the problems whatever we encountered, I think has been rectified. I think during this run, I hope that the equipment will run very smoothly. So I think thank you, sir, for the opportunity. Now it is over to you.
Thank you, Mr. Chandrasekhar, and thank you for correcting me. It was village, not the farmers. So villagers are more difficult to handle, it seems, than the farmers. Okay, thank you. And on this corrosion, yes, what he said initially, this was missed out. We designed the system mainly for bagasse, and after the analysis on Julia flora and all, we found that it contains some amount of chlorides, which was causing the corrosion. So now this corrective action has been taken, and this SS lining and SS portion is being, though the internals were all designed in SS, but the body of the scrubber was in mild steel. So that is being done now. Thank you so much, Chandrasekhar sir. Thank you for your time.
Thank you, sir.
Yes, friends, now you can see the pony sugar, clean stack, no more tiny balls, happy locality and the blaze. So this is what it is from pony case study. So I'll just now, before we close, I'll just run through two, 3 slides on the way forward to meet European standards in future. Because the time has come to use hybrid technologies. The single standalone technology will not work to reduce the emissions to so low in the given situations of Indian conditions. Number 2, there has to be some solution which not only, the air pollution can become a revenue generating. So these are the two areas where the Enviropol has been working for last couple of years, that how can we make the systems, APC systems, into a revenue generating model for the industry, and how can the existing system be modified and make hybrid to reduce the emissions. This is what is the target. And as you know, all the European countries, or most of the European countries, their norms are based on best available technology. And PM range is 2 to 5 milligram only, as against 50 we are talking today. SOx is 20 to 75, NOx is 65 to 85, and mercury is on 0.03. So in India, mercury is same, but SOx and NOx are much higher still in the norms, and PM is also much higher. So future lies in the hybrid technology, and these are the 4 hybrid technology which will find its own place in years to come, definitely, for making the emissions, the environment more cleaner and revenue generating for the industry. So first one is the hybrid wet ESP, as we discussed. I'm just concluding all the discussions what we have. The hybrid wet ESP coupled with a high biomass dryer. The second could be hybrid ESP, FGD, and wet ESP. So you have a conventional ESP. Suppose you have a fuel which has got SO2, then you can have a FGD scrubber followed by a wet ESP to have the clean gases down to 2 milligram or 3 milligram outlet emissions. So this is another integration of 3 technologies, in fact. Then this is hybrid ESP plus back filter, and this MEPA, ESP plus EGB to reduce the emissions. In this EGB, we are conducting a couple of trials to make it to reduce SO2 content also in the flue gases. In the same model, just putting up the lime with the gravels and reducing the SO2 absorption in the system. So these are basically the 4 technologies which are going to find their own place in the industry in the years to come, to make the system revenue generating or to reduce the emissions down to below 10 milligram. This is wet ESP, this is EGB. These are 2 promising technology which we have talked today. Wet ESP is a wet system, and the dry EGB is a dry system. So these are 2 categories of the system, and both has got a capability to reduce below 5 milligram if it is designed for the said purpose. So in the summary, what we have learned today, I'll just made some bullet points how you can approach to resolve your problem. First, we saw the reduced emissions, what it can impact on the environment, and what you can contribute to the society and to your next generation's health. So this is what we discussed in the first slide. Most existing APC devices are upgradable. By now, I think you must have seen all the type of upgradation possibility, be it wet scrubber, ESP, or back filter. All can be modified or all can be upgraded to reduce the emission norms. Cost of upgradation may not be as exorbitant as we thought for the complete replacement. In most of the cases, the this modification cost may not be more than 20, 30, 40% of the new system. So in any case, if this can work out for some factories, this is going to be a better option. There is no single solution for all the plants. I repeat this. A stand-alone or a standard scheme or tailor-made a standard scheme cannot follow in all the plants. Every plant will have its own tailor-made solutions depending on various factors. So a proper study, pre-study is required before we decide, or before you decide to convert or upgrade or replace anything. And considering the health of existing EPC is downstream system, boiler capacity, fuel mix, margins available on IDFAN, these are the deciding factors which will define the way forward for upgrading your existing technology. And to do this, there is a competency required to undertake this study. So my idea would be not to take these decisions in hurry. It needs a proper study so that your upgraded system can deliver you what it is expected to, right? So please hire some agencies to conduct the test, generate input data for the OEMs to study and suggest you the upgradation. And these are the various collaterals required for this study and implementation: the design and operating data on the existing ESP. Under MCR conditions, a competent agency person for proper data analysis and selection, an experienced APC company having complete product mix to avoid any biased opinions, and to have a boiler study that the system being upgraded should not adversely affect to the boiler operations. So these are the very basic elements wherein you can decide and take a call for upgradation or replacement of the equipment. So thank you very much, all my friends. Thank you so much for your patience hearing and stay connected till now. So we will be taking up the questions now from the chat box, and after that our backend team will connect with you and issue the certificate you can download from the system, right? So I'm just opening the chat box now. Please write your questions. Okay, thank you. So I will be taking up the questions now one by one. Mr. Nirav Mehta, the question is EGB MEPA can install in any existing ESP, or there may be some criteria. Yes, EGB can be installed in the downstream of any ESP, and it all depends on the type of fuel. If the dust is very sticky, then it suits your selection very much. If it is a normal dust, then it could be a luxury for you to have an EGB. So we can discuss this depending on the fuel mix, but it can be put up on any ESP after in the downstream. What is the fuel used in the boiler? I think this has been replied already by Mr. Chandrasekhar. In Pony Sugar, they have a different kind of biomasses. Mr. Sachin, cost of this installed additional fixed vane scrubber, this varies, depends from site to site. This was a 100 TPH boiler, and having the complete scope with ducting and damper, booster fan and scrubbers. So it will vary much depend on the layout of the system. So we can discuss on cost element on one-to-one basis depending on your site conditions. Mr. Rajendra Patil, please share the contact number of Mr. Chandrasekhar, sir. Okay, Mr. Patil, we will take his permission and share with you his number. Okay, Mr. Anil Mazumdar, I am from ITC Unit Triveni. We are facing problem of higher SOx and NOx. Mr. Anil, we can discuss separately because SOx and NOx abatement is a separate subject. We can have a discussion. You can connect us on one-to-one basis. What is the best for mustard crop residue? Fuel water is scarce for us. Okay. Mr. Anubhav Joshi, for mustard husk, there are two options available. I agree. Wet scrubber is a last choice for mustard husk. If you are not looking for a wet system, then the left out choices are either the Cyclo EGB, having a pre-cyclone followed by EGB, or a good quality bag filter. We have successfully commissioned a bag filter on 100% mustard husk, and maybe our next webinar is going to be on case study only. So you are welcome to join that and we discuss more about it. Mr. Anil, we have limitation in space. This fixed vane scrubbers has covered very small space, so as the EGB. So we can discuss depending on your boiler size and on one-to-one basis. Mr. Kishore, is the system okay for rock dryer having coal-fired furnace? Yes, Mr. Kishore, the system is perfectly okay for this application. Mr. Manish, sir, in the ESP or other device, plume phenomena works. Mr. Manish Shukla, sir, in the ESP or other device, plume phenomena work. Mr. Manish, question is not clear. Can you please address your question so that we can understand what you are trying to say? Mr. Bala Subramaniam, the question is, we sent an inquiry for dedusting system, metal recycling shredder, and had discussion with your team. They regretted that they can't design a dedusting system for our application. I will hope that you can make it. Okay, Mr. Bala, I will personally look into this once again and see what best can be done on your application. Is EZB can be useful to capture DG set emissions? Mr. Rajiv, DG set emissions may not be a good fit for EGB. You have other simpler system to deal with for DG set emissions, carbon emissions. Okay, please share training PPT. Sure, Mr. Ishwar, we will be putting it online and then you can download it through a link. Okay, Mr. Bala, we shall be sending you the email address. Mr. Ishwar, the Sarba writes, can we install cyclone back filter in slow fight boilers? Yes, you can do that, Mr. Ishwar. Cyclone back filter could be a good solution, but only thing is that back filter needs lots of careful operations and has got a recurring cost. So this decision has to be a techno-commercial decision for you by weighing the other type of systems available for this slow fight boilers. Mr. Rahul Rana, sir, existing ESP3 field, can I install a wet scrubber after ESP to control 50 milligram? Yes, of course, Mr. Rahul, you can do that. What is the additional power requirement for EGB system? Mr. Naval Kishore Sani, additional power is going to be, if you look at for a 40-ton boiler, it should be around 100 to 120 kilowatt to encounter the extra pressure drop across EGB. I think I've replied this. And then Mr. Nafis, we are facing a problem slurry jamming by using of a spray pond, water as clear water top for wet scrubber. Mr. Nafis, you can write to us, to our team. We can discuss this separately. I think it's a specific problem in your ash spray pond water. Mr. Dalip Kumar, does your system put in operation before the start of crushing season during steam trial when fuel feeding is not consistent? Yes, if you go for EGB, you can do that. Or if you go for cyclo EGB, you can do that. I think this was the last question. Thank you so much, friends, for your hearing. And now over to my backend team for taking it forward towards the closer. Thank you so much. If you have any more questions or comments, you can please share with us through email, and we will be happy to respond within 24 to 48 hours on your queries. Thank you. Over to Prakhar.
Yes, I have shared the link for the certificate in the chat box.
So you can tell them the process of downloading.
Yes, so everybody has to just click on the link and put their names and email ID and the rest 1 and 2 extra questions, and the certificate will be mailed to them after the submission of the form. And second step would be to showcase your certificate on your LinkedIn and tag us. We will share it on our page as well. If you are having any issue, you can just write in the chat box. If you have submitted the form for certificate, please type in submitted in the chat box.
Please write in the chat box if you have already submitted.
Everyone can download their certificate from the link given in the chat box. I am again sharing the link.
Friends, we shall be coming up with the next 2 case studies very soon, and our team will be in touch with you, communicate on the dates and the time. And the next webinar could be on mustard husk, this bag filter application, the case study, and then maybe on EGB on a slope fight boiler. So I would like to thank you once again for your support and for your involvement with us continuously for last couple of years. We have been interacting on different kind of technology. Look forward to see you in our next webinar. Thank you and have a good weekend. Thank you so much. With over 370 installations across 20 countries, Enviropol have been able to clean the air by over 12 million tons of solid particulates and 250 million tons of gaseous pollutants. This has made a positive impact in better agricultural growth, health and safety of human beings in the vicinity of the factories, besides creating employment and byproduct. Enviropol has been pioneer worldwide in supplying various new technology in the field of air pollution control. It is rated #1 amongst few Indian companies in the entire spectrum of air pollution control business. Hello friends, as you know, the industrial production is booming, so as the air pollution. Our present government is well informed on sugar mill in India.